Hi guys, so we continue with our look at the paper by Howard, and we figured out some things in 2.25, the theoretical foundation of public health interventions, where we said, look, in order for us to manage a disease, we must try to reduce the duration of the infection and also reduce the contact rate by self-isolation of susceptible individuals. And also we reduce the number of initial susceptible people by offering flu vaccines. So this is what we want to talk about, vaccination. There was point number 4, which was talking about reducing transmissibility by practicing good hygiene. Yes, but we are focusing on vaccination and its impact on disease transmission or its impact on disease propagation. So that is our discussion in this section. And we look at this work by Howard, what he suggests. Remember guys, at the end, when we are done with the look with our look on this paper, we are then going to criticize or positive criticism of the paper to say, look, if it was not educational as it is, what could be done to improve the writings of Howard? But right now, let's just take everything and learn from everything that he is giving to us. So what we have now is that vaccinating susceptible individuals, what it does is it removes the individuals from the susceptible class. So in other words, we are having the susceptible here going to being infected there, right? And then they will recover there. But now, if there is vaccination, a portion is getting vaccinated. So it means that we have got a class called vaccination there. And we are assuming that if you are vaccinated, you will not be infected. But we are also ignoring the fact that because of the assumption that once you have recovered, you are immune. So also you will not need to be vaccinated. That will not be necessary. All right. So we have got this thing that is happening here, that the number of susceptibles, some individuals are getting vaccinated, and then we end up with a fewer number of initial susceptible people. All right, but then there is one thing we know about vaccinations. They can work, they can be 100% effective, but the thing about the vaccine itself is that is it 100% effective as well. That is the efficacy of the vaccination that you are actually giving to people. So we realize that vaccine, even if a vaccine is 100% effective, so the efficacy is 100%, during a year when a flu vaccine matches the circulating strains, the annual flu vaccine is estimated to be about 60% effective. Why? Well, because vaccinating an entire population is very expensive. So we must think about this from an economical perspective to say, is it even affordable to do that? And also, because of beliefs, we saw with COVID-19 that not everybody was willing to take the vaccine. So some individuals, such as those with compromised immune system, because if you have got maybe some other ailment, some other chronic disease that you are suffering from, then it might be not possible. It might be impossible for you to take a vaccine because it might conflict with the medication that you are on already. So that is another problem. So it means that some people might not get the vaccine because they might suffer from severe allergies, and the vaccine may be worse than the disease. So the question that we ask now is, can an epidemic be prevented by vaccination only? Vaccinating only a fraction of the susceptible class. And what we are saying is that once you are vaccinated, you are immune. So, once vaccinated, you are immune. The idea of vaccinations, I'm not going to talk from a clinicist perspective, but I'm just going to say what happens is that if we vaccinate, what we are doing is we are introducing the virus to your system, right? But a manageable dose. So introduce the virus to your system. Why? So that your body system is going to respond. So we are going to get a response from your body. So your body is going to respond and adjust and eliminate. The very same thing that happens in here. You are infected, your body responds, it conquers the virus, then you recover, then you are now immune. So that is what we are doing when we are vaccinating. We are simply saying, let's introduce a managed or a manageable dose of the virus to your system so that your body is going to respond and conquer the virus. And now, even if the virus can come from somewhere or from anywhere, now your body is prepared to fight the virus. So now you are immune in that respect. So it means that once we vaccinate you, you are as good as a person that is here. So you are no longer belonging, you don't belong to the class of susceptibles. So the effect of vaccination, if we vaccinate quite a number, a significant proportion of the susceptibles, then it means that we are going to reduce the number of susceptibles. And that phenomenon that we call is what we call herd immunity. All right? Because what we require is that RE must be less than or equal to 1. So once we vaccinate and quite a number of people is vaccinated, what will then happen is that if RE was 3, it means that you were able to spread to 3 people. But then we have reduced the set of susceptibles, because that's where the whole idea, the whole issue lies, to be able to reduce the set of susceptibles. And then once we do that, it means that the virus will stay in fewer, or has got fewer hosts. It doesn't have a lot of hosts. And in that respect, also the ones that it might try to attach itself to, they have been vaccinated. So these ones will conquer the virus. It will not be able to spread much. And that's why we say, look, an epidemic can be prevented by vaccinating. Remember the definition of epidemic. We said that then there will be an increase until we get to a maximum, then a decline. But then what can happen is that we can have then a decline from the onset, and then it dies away. So we're not saying that the disease will not be there, the virus won't be there. It will be there, but that it doesn't develop to being an epidemic. Why? Because our RE is less than or equal to 1. So what is being said here is that if now we let rho here denote the fraction of the susceptible individuals who gets vaccinated. So these ones here, all right, these are rho. So we are now saying these are rho, and so we are going to remain now. Our susceptibles are not going to be, the remainder is 1 minus rho, all right? So we are going to remain with 1 minus rho in there. So if we say to move from S to I, we actually have beta, but now we are now saying, look, we actually have 1 minus rho S0. This is the initial number of people that are not vaccinated, and these are the susceptibles that we start with. So they have moved from the susceptible class to the removed class, and thus the size of the susceptible class just remains this one. So if we can have a higher rho, and if rho is equals to 1, then it means that we don't have anybody who is susceptible. That's what it means. It means that at the end of the day, we've got 0 times S0, and we have got nothing. Our RE is perfect. Remember the definition of RE. So that's what we have, the definition of RE that I'm talking about. We said RE is equals to S0 over N. Then we've got nu there, and we're using B there. All right. So if we now have some certain section vaccinated, we remain with 1 minus rho. That's what we remain with. And the more we increase this rho, the smaller this number becomes, and the smaller our RE becomes, and we are happy because we know that we are going to manage the disease. All right.